a multifamily service, regarding the application of Table 310.15b6 for the main service and feeder sizing to apartment service panels, the answer is yes. You can indeed utilize Table 310.15b6 for both the main service and the feeders supplying individual apartment service panels. Table 310.15b6 within the National Electrical Code specifically addresses the minimum allowable ampacity for service conductors and feeder conductors that supply dwelling units. It's crucial to understand that this table incorporates an inherent diversity factor. This diversity factor, implicitly around 35%, acknowledges that not all dwelling units within a multifamily building will simultaneously draw their maximum potential load. This allows for a reduction in the required ampacity of the main service and feeders compared to simply summing the maximum potential load of each individual unit. The intent is to appropriately size the electrical infrastructure based on realistic usage patterns, which are statistically less demanding than a worst-case scenario where every appliance in every unit operates at peak consumption at the same time. In a multi-family service application, the main service is typically sized to accommodate the aggregated load of all dwelling units within the building. However, this isn't a direct summation of each unit's maximum potential demand. Instead, the total load is calculated by considering the diversity factor inherent in Table 310.15b6 or through other load calculation methods permitted by the National Electrical Code, reflecting the expected simultaneous demand. Then the feeders that serve individual apartment service panels are sized according to the load requirements of each specific unit. This involves calculating the demand load for each apartment, taking into account the square footage of the unit, the number and type of appliances, and other relevant factors outlined in Article 220 of the National Electrical Code. Using Table 310.15b6 for both the main service and individual feeder calculations helps ensure that the electrical system is appropriately sized for the expected load, while also providing adequate protection for the conductors involved. By adhering to the ampacity requirements of this table, you are effectively safeguarding the system against overcurrent conditions and potential hazards. This approach optimizes material costs by preventing oversizing of conductors while maintaining a safe and reliable electrical installation for the multifamily dwelling. It is crucial to always consult the latest edition of the National Electrical Code and adhere to all applicable local amendments and regulations. Consulting with a qualified electrical engineer or licensed electrician is highly recommended to ensure proper application of Table 310.15b6 and compliance with all relevant code requirements. The table only applies to certain ampacity ranges of conductors such as 100 amps, 110 amps, 125 amps, 150 amps, 175 amps, 200 amps, 225 amps, 250 amps, 300 amps, 350 amps, 400 amps, 500 amps, and 600 amps depending on the conductor type and the voltage ratings. Remember to always consider voltage drop calculations and conductor temperature rating when sizing conductors, and ensure the calculated voltage drop does not exceed the recommended limits by the National Electrical Code or local amendments. These calculations are used to ensure power quality and prevent equipment malfunction. Also, remember to use appropriate overcurrent protection devices and grounding practices to ensure the safety of the installation and its occupants. It's important to note that Table 310.15b6 may not be applicable in all situations or for all types of dwelling units. For example, it might not be appropriate for dwelling units with unusually high electrical loads, such as those with large electric heating systems or extensive data processing equipment. In such cases, a more detailed load calculation may be necessary to determine the appropriate conductor size. Finally, keep in mind that the National Electrical Code is a minimum standard, and it may be necessary to exceed the minimum requirements to provide a more robust and reliable electrical system. For instance, you might choose to upsize conductors to reduce voltage drop or to provide additional capacity for future expansion.